Hi, I'm going to answer the question, what are capacitors? This thing here, this is a capacitor. It is made up of two charged plates with a dielectric in between them. Here we have a basic circuit with a voltage source and a series capacitor. The green arrows represent the way in which positive charges flow, and the red represent the way in which negative charges flow. Now let's take a closer look to see the way the current flows through the actual capacitor. One of the plates gets a build-up of positive charges while the other gets a build-up of negative charges. This creates a potential difference, which can be also referred to as voltage. Now let's look at another circuit with an extra branch and a switch. When the switch is in position 1, the capacitor is charging. And when the switch is in position 3, the capacitor is discharging. When it is in position 2, it is simply holding the charge it stored. Before we go any further, we need to introduce you to the concept of a time constant. The time constant is simply the product of resistance and capacitance in the circuit, and is represented by the symbol tau. A capacitor is considered to be in steady state if more than 5 time constants have passed in the charging phase. Whilst charging, the current and voltage through a capacitor can be represented at any time by these equations. Remember, tau is the time constant, R multiplied by C. This is the graphical representation of the voltage and current whilst the capacitor is charging with respect to time. When discharging, these equations can be applied to show the voltage or current at any particular time. Here is the graphical representation of the voltage and current while it's discharging with respect to time. Right, let's do a question. Here is a circuit with a series resistor and capacitor and a switch. The resistor is a 100 kilo ohm resistor and the capacitor is a 5.6 microfarad capacitor. The first part of the question is asking to just find the time constant. We do that by simply multiplying the resistance by the capacitance. Be sure to keep everything in SI units. The second part of the question is to write down the mathematical expression for the voltage Vc following the closing of the switch. To do this, we go back to our equation. The voltage across the capacitor is equal to the total voltage, all multiplied by 1 minus e to the minus t on tau, where tau is the time constant. Substituting in the values of e and tau, we get that the answer is 20 volts, all multiplied by 1 minus e to the minus t on 0.56 seconds. And that's my introduction for capacitors and DC circuits. Thanks for listening.